Hello everyone, and welcome to the DataFrames Part 2 lecture. Last time we left off on how to create a basic data frame and grab information from that data frame. Now we're going to look at conditional selection as well as some multi-index parts of a data frame. Let's go ahead and jump to Jupyter Notebook to get started. Alright, here we are back at the Jupyter Notebook. I'm going to be using the same data frame as last time. So remember we just had to say numpy is np, pandas is pd, import rand_n, set the seed to 101, and then say the data frame was rand_n 5, 4. And then here we have our data frame. Okay, let's go ahead and talk about conditional selection. A very important feature of pandas is the ability to perform conditional selection using bracket notation, and this is going to be very similar to numpy. For instance, if I use a comparison operator against the data frame, such as asking where is the data frame greater than 0, I will get a data frame back of Boolean values, where it returns true if the data frame value at that point was greater than 0, and false if it was not greater than 0. And this is very similar to the same conditional selection applied to an entire numpy array, except in this case we're doing it with pandas data frames. And just like this, we can go ahead and say bool df is equal to df greater than 0, and then say bool df, go ahead and check that out. And here we have our Boolean data frame. And if we pass that in to our original data frame with bracket notation, then we will get out as a result values where it was true and nulls or NaN where it happened to be false. And that's the way you can use conditional selection along with a data frame. Now usually you probably wouldn't be separating this out into two steps. You would just say df and then in brackets something like df greater than 0, and you would get this result. This sort of operation with a data frame and against a comparison operator isn't that common. What most likely you'll end up doing is instead of just passing in the entire data frame, you'll pass in a row or a column value. And instead of returning nulls, what that's going to do is return only the rows or columns of the subset of the data frame where your conditions are true. Now let me go ahead and show you an example of what I mean by that. Let's go ahead and take a look at our original data frame. Here we have rows A through E and columns W through Z. What I'm going to go ahead and do is specify df of W greater than 0. And notice I get a series back. True, true, false, true, true. And this is linked to the actual index. And if I take a look at the W column, I see that this corresponds with the W column values. And the value at index C was actually less than 0, so it returns false for being greater than 0. I can now use this series of Boolean values corresponding to rows to filter out rows based off of a column's value. And that means if I pass in this series into a data frame using bracket notation to say something like df of dfw greater than 0, I will only get back the rows where this happens to be true, meaning I'll only get back the rows A, B, D, and E. It won't return row C since it was false here. Let's go ahead and run that and see what this looks like. Great. And now, since I'm passing in a series, I don't get those null values anymore. You only get those null values when you're doing this sort of condition on an entire data frame. When you're actually passing in conditions based off of columns, you'll just get series values, meaning you'll get only the rows where it happens to be true. And this is the sort of conditional selection we're going to be using most often throughout this course. Let's go ahead and show just a few more examples to really drive this point home. Let's say I want to grab all the rows in my data frame where Z is less than 0. So I say df, where df of column Z is less than 0. Now let's take a look before we actually run this, what should happen. Well, we'll notice column Z, where is it less than 0? Well, that's only occurring in row C. So column Z, as in Zelda, and then row C as in cat. Here, this is the only row that should be returned. But remember, we're asking for the entire data frame back, so it should return just this row C for us. And there it is. Okay, great. Now, something else to note here is that when you're doing these sort of commands, let's go ahead and go back to our W greater than 0, you get a data frame in response. And that means you can go ahead and call commands off of this data frame. Then you can do this either in one step or two steps. I'm going to go ahead and say result df is equal to this, and then take a look at result df, which is this subset of the data frame without that row C in it. And that means I can go ahead and grab results off of this, such as x. And here I have 4 values of x, a, b, d, and e, based off of this resulting data frame that didn't have that row C in it, as in Charlie. But instead of actually separating this out into 2 steps, such as grabbing the x column, I can do this all in one step. And let me show you what I mean by that. I can go ahead and say, return the data frame where the column value of w happens to be greater than 0. So return those rows to me. And that means all the rows minus the C row. And since this is a data frame, I can actually go ahead and stack commands such as bracket notation on top of that, such as return the x column where that's true. And now I get the same results as I did up here, except it's all done in one step. And this is something that can be intimidating to beginners at first, since there's a lot of brackets and a lot of stuff going on here. But essentially, this is just, instead of splitting everything up into multiple steps, I'm putting it all into one step. And likewise, since this is a data frame, I can bracket for multiple columns by passing in a list, such as y, x. And we can see we get a result here. Let me go ahead and break this line down one more time to show the steps that we're taking. First off, we're going to go ahead and say bool df is equal to, well, let's go ahead and say bool series, since that's a little more accurate, is where dfw is greater than 0. So if I say bool series, I get this Boolean series back. Then what I'm going to go ahead and do is say result is equal to df of that bool series. Let's go ahead and check out the result. And it should just be wherever that series was true, which is A, B, D, and E. And there is my result. That's the entire data frame without the row C in it. And then I can go ahead and off of that result, call a list of columns. So we can go ahead and say y, x. And if we wanted to, we could actually even separate this out into one more step by saying my calls for columns, pass in that list, and then say result of my calls. And we get the exact same thing we have here done in one line as in multiple lines. That means if you're ever confused on something that looks like this with a ton of brackets and pandas, see if you can break it down into multiple steps if that makes more sense to you. Throughout the course, we're going to be doing this type of notation, these kind of one-liners, and as you get more and more comfortable with pandas, you'll find yourself using these one-liners more and more often. But if you're ever confused, always feel free to break it down into multiple steps. The only disadvantage as far as breaking it down to multiple steps is that you are taking up memory with each variable that you define. So as you get better and better with pandas, you'll want to move towards this simple one-line abstraction of all these commands. All right. Go ahead and pause the video now and really make sure you understand how line in 58 here is the exact same thing as separating it out into multiple lines. All right, let's go ahead and explore real quick the concept of using multiple conditions, such as 2 or more conditions. Right now, we feel comfortable with doing something like this, which is returning a subset of the data frame based off of one condition. But what if you wanted multiple conditions, such as where w was greater than 0 and y was greater than 1? Well, what you could do is try something like this. Is in parentheses, pass in one condition, and then say and, pass in another condition. And this is going to return an error, and I'm going to do this on purpose to explain why there's an error happening here. And this is a common mistake for beginners to put this and here. And you'll get a mistake that says something about the series being ambiguous. If we scroll down here, we see this. The truth value of a series is ambiguous. And what that is trying to say is that Python's normal AND operator can't actually take into account a series of Boolean values compared to another series of Boolean values. An AND operator can only take into account single Booleans at a time. So true and false returns false, true and true returns true, etc. That means when you pass in an entire series of Boolean values, such as this, the AND operator begins to get confused. it can only deal with these single instances of Boolean values, which is why when you're working with pandas and you want multiple conditions, you actually have to use an ampersand, which is this and. So that's going to be Shift 7 on your keyboard for most standard keyboards. And notice here that I'm passing these conditions in parentheses to show clear separation between each of those conditions. And then if I run this, I get the row E where this happens to be true. Okay, let's go ahead and break that down one quick last time. When you're trying to use multiple conditions, you can't use Python's normal AND operator. You have to use the ampersand. And then you pass in the multiple conditions in parentheses, and then finally you put it inside of brackets for your data frame. If you want to do an OR operation, you can just replace this with the pipe operator, which is right above your, usually for most keyboards, on your enter key, go ahead and go right above it and then do shift on that backslash, and this should give you the pipe operator. And that's going to be your replacement for OR, because if you try using OR, you'll get the same error. So that's with OR. If I try it with Python's normal OR, again, I'll get the truth value of a series is ambiguous. And that's because you get a series of those values instead of just one or two Boolean values. Okay, you can go ahead and reference the notes if you want more examples of this, but basically, if you want multiple conditions, pass in each condition in parentheses, and then use an ampersand or pipe operator for the AND or OR. Let's go ahead now and shift gears to talk about index and a little more details about it. What we're going to discuss now is resetting the index or setting it to something else. Let me go ahead and take a look at our original data frame. I'm going to go ahead and clear these cells here by just running them. And let's take a look at our data frame. Again, we have rows A through E and columns W through Z. In order to reset the index back to the default, which is just a range index, 0, 1, 2, 3, 4, all the way up to the nth row, what you can do is call the method reset underscore index. And remember to close parentheses that we actually run that method. And if you call that, notice you will get the index reset to a column. And you'll get the actual index then to be numerical. And that's how you can reset the index. Something to note here is just like a lot of other pandas data frame operations, this doesn't occur in place unless you specify it for it to occur in place. So if I call back df, I still have that original index of labels. If you want this to actually occur in place, what you would just do is say in place equals true and pass it into the reset underscore index. For now, we'll go ahead and not do that. That way we still retain our original data frame. Let me go ahead and clear this out. Again, if you just want to reset the index to a numerical value, you can just use .resetIndex, and your old index will become a column of your data frame. Okay, let's go ahead and show one more new index example, such as setting the index. And in order to do this, I'm going to go ahead and create a new index called new IND. And I'm going to use a little trick here that I'll explain in just a second. This is going to be a bunch of state abbreviations, and I'm going to say .split on this string. And remember, .split off a string is just a common method for splitting off a blank space, but this is a nice quick way to create a list instead of having to type out every comma. So I'm going to go ahead and set that list equal to new IND, so I have my new index values here. And what I'm going to do is put this as a column in my data frame. So I'm going to go ahead and say df states is equal to new IND. And since the dimensions match, so there's 5 items here, it will match from 0 to 4 here on this data frame. So if I check out my data frame, I have this new column called states. CANYWYORCO. Now we know how to reset the index, which is just doing the .reset underscore index method. But if you have a column in your data frame that you want to be the index, what you can go ahead and do is say .set index instead of reset index. For example, I can say df.set underscore index and then pass in the column name you want to be the new index, such as states here. And if I do shift enter, now the states column has become the index. Keep in mind, unless you retain this information of the index, this will overwrite your old index and you won't actually be able to retain this information as a new column. unlike reset index that allowed you to have that new column. So that's set index versus reset index. Again, if I check out my data frame here, this wasn't in place. I would need to add the argument, if I do shift enter here, in place equals true. Let me go ahead and just do a quick review of what we just covered before we head up to part 3. Okay, we learned about conditional selection, which is very similar to NumPy operations. You basically get a data frame of Boolean values, and if you pass in a whole data frame of Boolean values, you'll get the values where it's true, and you'll get NaN or null values where it was false. If you pass in a series of Boolean values, such as a column with a comparison operator, you'll end up only getting the rows of the data frame where the series happened to be true. And you could break this down into multiple steps if you wanted to. Again, these two cells are probably the most important to understand out of this lecture. If you understand this, then you understand how to do conditional selection in pandas. Then, scrolling down, if we wanted to do multiple conditional selection, you could do an ampersand or a pipe operator. You cannot use Python's built-in and or operators because of the ambiguous values in a truth series. And then remember to use parentheses to separate each conditional selection statement. Then finally, we have reset index. Reset index is just going to reset your index to a numerical index and take your old index and set it as a new column called index. And then you can set a new index instead of resetting a new index based off a current column just by saying set_index. And both these methods are not in place by default, so make sure to specify in place equals true if you want the change to be permanent. All right, that's it for this lecture. Thanks everyone. I'll see you at the next lecture where we will discuss index hierarchy. Again, all these notes are just in the notebook called DataFrames. Thanks, and I'll see you at the next lecture.